Hi students. Now we're going to look at formulas for arc length and sector area with radians because again, sophisticated mathematicians. So I know that you're going to default and think about degrees. So if I'm thinking about the length of this arc, well, I know it's a fraction of the whole circle. And I know in my whole circle I have 360 degrees. So this fraction of the circle is theta out of 360 degrees. So that, of course, is assuming theta is being measured in degrees as well. So let me come in and put in a note that this is our fraction of the circle. So fraction of the whole circle. And I want a fraction of the circumference. So my circumference is, I'm going to multiply that by 2 pi r. So this is my circumference. I'm going to stop there because I don't actually know how to spell circumference. And so I could simplify that. But again, we are sophisticated mathematicians, so let's actually look at how much better this is if we use radians. So assuming my theta has been measured in radians, I wouldn't say out of 360. I know a full circle all the way around is 2 pi radians. So when I think about writing this formula instead with radians, I would have my theta being measured in radians, so theta rads, out of a total of 2 pi radians times my circumference, which is 2 pi r. Well, look at all the canceling we have. 2 pi and 2 pi cancel, and I get that the formula for arc length is equal to theta times r. And this is going to end up being in whatever units r is. So that's going to be a unit of measure, unit of length. Notice that I've got radians over radians because I have 2 pi radians in my whole circle. So really, my units are canceling as well. If this was degrees and degrees, that would also cancel. If I think about area, well, we've got the same idea. You'd have theta over 360, except this time my formula for area is pi r squared, ugly and clunky, or theta over 2 pi times pi r squared, and my pi's cancel, and I end up with 1/2 theta r squared as my shortcut for area of a sector. Now let's think about a segment. This is a bit more challenging. So I've put in the picture to help me think about my segment. Remember we said a segment is defined by creating a chord. So a chord does not go through the center, and my segment is the area chopped off. Well, if I then do connect it back to the center, so I'd connect back to the center, which is what we did here. Now I have a sector minus a triangle. So segments are equal to sectors minus triangles. I'm just going to go straight to using radians. So my segment area is going to be my sector area. Well, we just said that a sector is 1/2 theta r squared minus area of a triangle is 1/2 length of side, so r squared times sine of theta. Now, if I wanted to, I could factor out the 1/2 r squared and have theta minus sine theta. Notice you cannot factor out the theta. They are the same value, but this theta is an input to the sine function. This is not multiplication, this is a function. All right, so those are our formulas. You don't need to have those memorized. We'll give them to you on any sort of formula sheet, but you do need to be able to use them. And in the next video, I'll come back and show you how we use them.